everybody. Welcome to the Construction Record Podcast. This is digital media editor Warren Frey, and with me today I have
Marc Goldman, the Director of AEC Industry Solutions at Esri.
And Rex Hansen, Principal Product Manager for the ArcGIS Runtime and Maps SDKs.
And we're talking about two things that most people don't know go together, like Reese's peanut butter cups, but they do. It's Unreal Engine and GIS. So if we could explain to start with, because some people don't know what Unreal Engine is, some don't know what GIS is. What is GIS first, and what is Unreal Engine, and what are game engines, and how do they relate to what we're talking about in the first place?
Well, I'll start off with what GIS is. It stands for Geographic Information Systems. Mm-hmm. It is commonly, experienced as digital mapping, and it's applied to just about every industry you can imagine who wants to understand where things are and how they relate to the job they do. So, my focus is architecture, engineering, and construction. So you can imagine the element of location being critical for when buildings and roads and cities get planned. You want to know where things are in relation to each other to do your spatial analysis and visualizations and produce better designs leading to better projects. So GIS historically has been 2D maps. It is quickly evolving into 3D experiences full of different layers of information. I'll stop there.
Great. And then I could talk a bit about game engines. So game engines themselves originated around building gaming. They're targeting gaming experiences. The idea is these are developer technologies that are designed to deliver high performance, premium rendering of content, fast and fluid interaction to really kind of meet and compete in the sort of gaming space, games for entertainment. Oftentimes those are very immersive experiences. So you have very high fidelity 3D interactive experiences that are built out with some of the most popular game engines, such as Unreal Engine or Unity. Mm-hmm. And so what we're looking at here is trying to combine, really bring GIS and the geospatial capabilities that are delivered through Esri to game engines, right? To take advantage of the geospatial data, accuracy, the content that's available through basically digital twins within the world for maybe different local or global spaces. Bring that information into a gaming engine or a game engine, mm-hmm. so that we can take advantage of some of those high performance and premium rendering experiences for a greater interactivity and more immersive experience.
Right. Now, I know this is something people might be more familiar with. The TV show The Mandalorian and several others do this with, when you see a background, that's Unreal Engine over a screen. So you guys aren't doing that, but that's the fidelity we're looking at. That's something that's good enough for that. So I'm assuming that somebody using your systems would experience that sort of same level of immersion, more or less.
Indeed. I think the key there is the experience, right? So it needs to be a virtual representation of the real world. Mm-hmm. And so that you can immerse yourself into something that feels real, that interacts with, or at least you can respond to or work within that environment, in a virtual environment, in a real way. And so it's really about trying to bring physical reality to the digital world, so that we have a true to life digital experience.
What's unique, though, when we talk about this from the perspective of industrial workflows versus gaming environments, in a gaming environment, you want the physics, you want the textures, you want the lighting, all to be as realistic as possible, but you don't necessarily, you're unlikely to click on a door and want to know its properties, or right. You care that you might move that door and the wall will heal itself when the door is moved. These are the kinds of things that you expect in architectural tools, CAD tools, building information modeling tools, and GIS tools. Those same kinds of capabilities with the immersiveness and the quality of visualization and the ability to experience those scenes on a desktop with a set of VR or AR equipment really opens the door to a whole lot of conversations that you just couldn't have had 10 years ago with your clients, interacting with models at that kind of immersiveness just makes the client designer conversation completely different than it would be in front of a CAD screen or in front of 2D drawings.
Mm-hmm. Yeah, I mean, the idea of digital twins has been around for a while, and so has even been scooting around within a monitor, but this sort of expands it. I mean, GIS to me means more surface area to begin with. Like there's more you can cover here than you could before.
Yeah, it's context. That's one of the things that you can't undersell the value of GIS, is the ability to bring in context, whether that's the city grid and aerial imagery over it, or data that helps convey an environment, a situation, census data, or a kind of, on-the-fly collected data that would help a designer or engineer convey to their client, what is going on in this intersection, at this roadway, on this campus. Just again, in ways that a static 3D animation, by static I mean you rendered it out and now it's done and then you are done with it. These are real time, by many definition, interactions with data. And that's pretty powerful.
I should probably mention that just to build on what Mark said, is that one of the benefits here of working with the game engine is that game engine organizations have taken have built out really an engine that provides the introduction and the visualization of high fidelity assets. You include physics engines, animation properties, atmospheric capabilities, water and other special effects that allow those who are working with the game engine to be able to bring their landscape to life. What's interesting is that a lot of times those are manufactured experiences, manufactured landscapes. What we're talking about here is taking the fidelity and the richness of real true world geospatial information, right, that comes from Esri, comes from GIS, and really match that or utilize that more effectively within this game engine space. We can take advantage of those assets, physics engines and animation properties, so that we bring our basically digital representation of the real world to life in a game engine. So that maybe in a game you might not click on an item to get more information about it, like a door, or open the door or something. But the interesting part is that does that door represent a door that would exist in the real world? Does the building that the door was in actually represent a building in the real world? Are you trying to build an experience that allows for someone to visualize or at least imagine what what the physical representation of that digital information, that geospatial information, would look like and perform or act like in the real world? And I think that's where game engines really are designed to bring our geospatial information, the fidelity and accuracy of our geospatial information to life, whether that's imagery, it's features, it's 3D objects, whatever is used to represent more realistically the world that we live in a digital way.
Now, there's a lot of, I hesitate to say legacies because it's not that old, but there's a lot of different systems that people have been using to do this. How does that integrate into this? Because I would assume people want to use the data they've already got and put it into this to work with it. Otherwise, they don't want to build everything up again from a new system.
Yeah, GIS is a great connector and collector of lots of data. And over the last few years in the area of the built world, our ability to either import directly or to integrate with the sources where data might already exist in the design world, different repositories such as Autodesk Construction Cloud or BIM 360, we're connecting to those environments so that the models that architects and engineers are working with or contractors are using to plan their work are brought in directly into the GIS environment, just like another layer of information. For that matter, point cloud data and satellite imagery data all brought together. So GIS is pretty unique in that way. As ArcGIS platform, it has always been this connector of information to then be analyzed in various ways, and it's kept up with, if not even kind of led the charge in the use of and the access to 3D information in web browsers, in mobile devices, and connecting it all to various workflows. So it's a pretty strong place right now that the information you do create in the design process, in the construction process, is not lost, but is instead actually becomes either an archive for that digital twin conversation, or it's the real-time data you need for getting construction completed. One of the most interesting workflows, something you were talking about earlier, Rex, as far as the visualization of information, was an example of GIS data brought into the immersive environment of Unity, but then also web services connected to the scene that were the actual loop, the train in Chicago service schedule. So that as you were interacting with this downtown Chicago environment using real BIM models that have been created elsewhere, as well as some programmatically generated content, you were seeing the train service go based on its real schedule. As highly visual as you would expect in Unity, and as full of data as you'd expect in a GIS view. So it's really a great mashup of, let's call them the most modern technologies to deliver just a level of information you couldn't get any other way.
Mark, are you talking about the Halcyon Levine demo?
Am. Yes, I am.
Okay. Okay, great. Yeah, great. So just to clarify, that used Unreal Engine, but again, it's another game engine. But the interesting, just to kind of build on that, is that what that provided was an accurate representation of structures within downtown Chicago, but also then brought it to life by not just making the spatial representation accurate, but also time. And so being able to see things move in time and interact with those experiences and be able to basically visualize a prospective construction project, right, at different levels or different ways or different types, different options, but view that in an immersive manner, in an interactive manner, in a more realistic sense, I think provides decision makers, policymakers, and those involved in a project such as that, gives them more tools at their disposal to be able to make a better decision, actually, more realistic decision that will impact, or that will eventually impact our physical world.
And speaking of decision makers, I would assume, with multiplayer games have been around forever and people just hop in and play the games. Like, I would assume this allows for, because it's based on a game engine, allows for that level of collaboration, except with real world data from remote areas and anywhere else you have to be. You can just jump in and work on stuff, same as everybody else.
It does. I think, going back, Warren, to what you mentioned before about, talking about data and being able to integrate with existing data sets. And what's interesting there is we are seeing, so I'll talk about the ArcGIS Maps SDKs, right? So these are new developer tools that Esri has released to really bring GIS to game engines, right? To be able to enable access to ArcGIS, the breadth and depth of the ArcGIS system within a game engine context. And so there's really two things that provides, that the ArcGIS Maps SDKs for Unity and Unreal Engine provide. They provide a geographic context, a geospatial context or canvas actually within the game engine. Prior to this, it was difficult to work with, double precision, high precision data, geospatial information within a game engine, and retain that level of accuracy. So you're working with relative space, and in this case, we want to be able to work with absolute space, a representation of the globe or a local area that represents the surface of the Earth, and being able to render data that's part of your GIS, part of your system, in that context or on that canvas, in a way that you can use it in an accurate and truly representative way of what exists in the physical world, or what will exist, or what will happen within the physical world. And so we see some examples of that. For example, I mentioned CIMIC Group, EIC Activities. They're building out an application called Virtual Builder that allows for them to use the ArcGIS Maps SDK and their existing ArcGIS system, which they have in place and is servicing other client applications, to be able to bring in really a geospatially accurate canvas on which they can use the geospatial context to overlay additional buildings or structures, add additional assets that might be coming from other sort of third-party or non-Esri sources, and be able to overlay those accurately in geographic space, so that they can represent really a construction project. And what that application is designed to do is to provide an immersive visual way to see how a construction project will proceed and plan for that, going forward. What it's designed to do is reduce cost, because they can have a visually accurate representation of what that project will entail and all of the assets that are required and all the additional infrastructure that's required to be able to build out a project. So they've been very successful in that space. We've highlighted CIMIC Group and EIC Activities specifically in our blog post on release for the ArcGIS Maps SDK for Unity a couple months ago. And so we have some examples there that showcase some of the benefits to building in that game engine experience, but also mashing up, providing a geographic canvas, but also mashing up sources of data that you have that are geospatially aware, as well as others that can be interacted with or utilized within that geospatial canvas in a more accurate way. So it doesn't require, obviously we're trying to bring GIS and really the breadth and depth of ArcGIS to game engines, but it doesn't mean that you have to use ArcGIS completely. You can bring in other assets from other sources, and you can interact with assets that exist within the scene, within a game engine, as long as you have that geospatial canvas with an accurate representation on the surface of the Earth, basically, in geographic coordinate space. And so that's what we're providing. We're providing, with the Maps SDK, a geospatial canvas on which to paint your information, and then also ready access to the ArcGIS system and data sources that provide or deliver geospatial information that you can utilize in your sort of game engine experience, basically.
And in terms of scaling it up, I mean, I don't know what scale is to begin with. So how scaled up can you get right now, and where do you see this going in the future in terms of expansion?
I guess, if I talk a little bit more about the, where we see the integration with game engines going, we're at the start of a long road. We're just starting out, and I'd say at this stage we have a beta program that we started with these developer products just about 2.5 years ago. We've got about 7,000 users, customers, actually in that beta program. It's by far the most popular developer beta program we've ever had. A lot of interested parties in that space, and what we're seeing is that a vast majority of those users, of those customers, are working with a GIS already. They're usually working with ArcGIS already, and they want to take their gathering, curating, creating, and delivering data for both 2D and 3D context in a variety of different ways. And they want to be able to take that information and leverage that in a better way, in a more immersive fashion. And so that's where the game engine really allows them to bring their data that they already have within a GIS to life, right? So they want to be able to bring it to life and make it interactive and make it immersive, make it compelling, right? So it might be able to tell a story, whether that's for customers, their customers, or for decision makers within their industry. It provides a more compelling way to be able to communicate geospatially with their users and their customers. So we see a lot of that today. That's a vast majority of the customers in that space. We do also find is that there's a number of organizations that aren't using a GIS, right? They're still building business applications, but they don't necessarily understand or they want to understand now how a GIS can benefit them. And so they might choose to, build out or leverage GIS capabilities that Esri provides. They might choose to want to use data sources that Esri delivers, the hosted data sources. And so they're looking to Esri to be able to provide hosted data for, let's say, elevation, terrain, building data, building footprints, features, you name it, something to provide them with a source of data that they can use that's authoritative, that they can use in their applications moving forward, and maybe overlay that with operational information. Think of like weather data overlaid on top of, let's say, imagery that represents a region of the Earth.
Right.
So we see some customers that are saying, well, I don't need the full breadth and depth of a GIS, but I do need access to geospatial information. So can you provide that to me? And I have to admit, within the business world, we find that a lot of those customers are more willing to accept, there's going to be some, level of latency, or there could be some, some lower resolution data, but as long as they have something that they can act on and display and utilize, they're willing to move forward with that. There's another group actually within this section that isn't using GIS, but they have a lot of familiarity with game engines, and that tends to be developers that are building games for entertainment. That's a different world. At this stage, there's fewer of those, but we're seeing a lot more interest in that space. Now, I have to admit, that section, we would like to see that grow and expand. We want, game developers who are working with game engines that are very familiar with game engines to be able to take advantage of real world data in their experience. The challenge there is that we need to be able to provide, in most cases, they're not going to build their own GIS, right? So they're going to,
right, of course not,
they're going to look to Esri to be really a data provider, a services provider for them. And so they're going to need not just accurate data, but high performance data, right? And it's going to need to be at a resolution that's appropriate for a gaming experience. There's a lot of competition in that space. And so we're embarking, really on the Esri side, we're embarking on an effort here to deliver that high fidelity, high performance hosted data in a variety of different capacities to really power that experience for game engine developers who are building games for entertainment. Of course, that will sort of flow down and benefit those that are actually using game engines for business purposes too.
Right.
But that's kind of a longer term effort. It's a smaller group right now. We'd like to see that grow going forward. But it's interesting how really the demands of a game engine and that fidelity that's required in that experience are really driving some of the service-based capabilities and data sources that we as Esri will be hosting in the future going forward. So it's exciting to see where that's going to take us.
And just in terms of adoption, if somebody's in a beta program, they're obviously interested, but construction is also quite fickle when it comes to technology and sometimes resistant. So have you seen people just go, oh, I understand this. This is more like what I'm used to in everyday life, or have you found a little bit of pushback in terms of how people deal because it's just so new, or what's that reaction been?
Industry trend-wise, there's never been a time in my 25 or 30 years in this space that I've seen tech adoption so accepted and recognized as a differentiator, as a necessity. Generational shifts and various other reasons point to, the industry has been fickle and slow, but it is on an uptick of technology being a means of staying competitive and delivering great offerings. So that's exciting. I would say that the folks in the industry who have dabbled with and become proficient with 3D modeling as either a replacement or a supplement to the 3D models that they've built over the many years, either as fabrication models or as design models to help a large audience understand what a project might look like. Those firms who've embraced the likes of Maya and 3D Studio and Blender and other visualization tools, which typically result in dead-end animations, singular animations, but they've served a purpose. Those are likely to be the early adopters of immersive technologies, as their clients expect more than a single animation at airplane height, but they actually want to go down to the street level, or they want to actually go first person view. Those things you just couldn't do and can't do in the types of tools that I just kind of rattled off. Using the combination of context that GIS delivers and the visualization qualities of gaming environments, they're going to become mainstream. And it's like always, you're going to have your tech leaders who've been on the leading edge and bleeding edge of visualization and simulation are going to be the ones, and are the ones who are adopting this early on.
Okay, and finally, for both of you, if people are interested, and I'm assuming people are interested in finding out more about the gaming engines and what you guys are doing with them, where should they go in terms of information?
I'd recommend going to our developer site, so developers.arcgis.com. That's the place where you can gain access to these tools. You can also learn about what they do and how to use them. That's a great start at this stage.
Yeah, I'd say if you want a direct connection to the folks at Esri who are focused on AEC, AECinfo@esri.com will drop into a number of people's inbox, and we can take things further from there.
Okay, great. Thanks for joining us today, guys.
Cool. Thanks, Warren.